Today we're going to talk about, it's section 7.7 in our textbook. We're working on factoring special cases. The first one that we're going to look at is factoring a perfect square trinomial. Before factoring it, I want to show you what it looks like when we actually multiply it out. So if we're squaring a binomial, that means we're taking like a plus b times the quantity a plus b. When we do that, the first using FOIL, we would have a squared, and then the first and the last end up being ab, and then we would have ab again, and then we would have the last squared, which would be b squared. And so when we're looking at this finally, it's a squared plus 2ab plus b squared. What this looks like in terms of numbers would be if we had x plus 7 quantity squared. And we did this before recently, where we are squaring special cases. So if you remember, we were taking the first term and it's squared, and then we're adding it to 2 times, since there are 2 in the middle, this number here and the number in front of the x, which in this case is the 1. So we have 1 times 7 times 2. We would have 14x, and then plus, we square the last term, which is 49. Okay, so what we're starting to work at right now is to actually factor it when we start out with something like this. When you start to factor things, remember I've been telling you, ultimately it's your choice on how you're going to do something. So, and one of the first things we look at is to see if we can factor out a number, which in this case we can't. But something else that we need to look at is when we look at this last number, and we see that it's a perfect square, meaning you can take the square root of it. That's your clue that we can probably factor that into factor it easily without trying to list factors and finding out what the middle is. And what I'm going to do is I know that this first one I can take the square root, and then I can take the square root of that and get 7. And what happens when I times this 7 by 2, I get 14. And so since it works, meaning since the square root of 49 is 7, and 7 times 2 is 14, this is going to be the factored form. So you automatically know that if I were to factor x squared plus 14x plus 49, it is going to be x plus 7 quantity squared. Okay? And that's just something with practice, you start to recognize it a little bit more quickly. The other thing that can happen is sometimes, we don't always have a 1 in front of our x squared. So if I have 9x squared minus 30x plus 25. And when I look at this, the first thing I see is all those numbers that I don't want to work with. First thing I'm going to try is to see, can I divide these numbers by 9? I can't. But what I'm looking at right now is I can take the square root of this, because the square root of 9 is 3, and the square root of x squared is x, and I can take the square root of 25, it's 5. Which means I'm looking at probably something that looks like this. The only thing I have to be careful about now in this case is my sign, because my sign in here, since this is negative, this would have to be negative. Okay? And when I look at this, to double check to make sure if it makes sense, when I'm going from here to here, remember, this is squared. Yes, that's correct. The inside is going to be, the minus 30x is going to be this number, the 3, times this number, the 5, negative 5, times 2. 3 times negative 5 is negative 15, times 2 is negative 30. And it works. And then the last one is going to be negative 5 times negative 5, which is 25. And so then this is my factored form of 9x squared minus 30x plus 25. If for some reason you can't remember this or figure it out right away, you can use any of the other ways that we've factored things to figure it out. It's just, this is a way that's just a little bit faster. It's just like I said when we were doing the multiplying of those binomials, that some of you will catch on right away and some of you might take a little bit before you have your aha moment. Let's practice a couple more. We can try 4x squared plus 12x plus 9. Again, when I look at this, I'm looking at the front, I'm looking at the back. I can take the square root of this, I can take the square root of that. 2x. All my sides are plus, so this is going to be a plus. I can take the square root of 9, which is 3. And I have 2x plus 3, quantity squared. Just to check the inside, 2 times 3 is 6, times 2 is 12, so it works. And there's my factored form of that. We'll do one more. X squared minus 8x plus 16. I can take this. This is a perfect square. This is a perfect square. So there's my clue. When I'm looking here, I have a negative and a positive, so I know my sign is going to be subtraction. I take the square root of this, which is x. I take the square root of 16, which is 4. And then just to make sure it actually works in the middle, 1 times negative 4 is negative 4 times 2 is negative 8. So that works. And that's how you would do that part. I now want to talk about factoring a difference of two squares. But before we do that, I want to start with the binomials and multiply them. What we're talking about is when we have the very first term in each binomial, it is exactly the same as the second term. The only difference is one is plus and one is minus. And remember when we did that, we end up squaring the first two. The sign is subtraction, and then we square the last term, so it would be x squared minus 4. Again, the stuff in the middle completely disappears because it would be plus 2x minus 2x, and they cancel each other out. So now when I decide to factor the difference of two squares, and that's exactly what it means. Difference is subtraction, and two squares. I have a perfect square here, and I'm subtracting a perfect square here. So when you look at that and you recognize that right away, without, after a while, without even thinking, you just know, oh, I know what that means. It's where I have two things in parentheses. It's the square root of the first term, the square root of the second term, and one time it's plus, and one time it's minus. And so that's just your answer there. That's all you have to do. There's nothing that you have to figure out at all in order to do that. X squared minus 64 would be square root of x squared is x. Square root of 64 is 8. 8 times 8 is 64. So it's x plus 8, x minus 8. X squared minus 100. Same thing. X plus 10. X minus 10. Okay? Again, it's just some things you practice that you'll recognize, but your first clue that you have to start realizing is the first thing is squared and the last term is also a perfect square. And that's your clue on what's going to happen next. Moving along, one thing we need to start looking at is, the first thing we need to look at is to see if we can work with simpler numbers, smaller numbers. I'm always saying I like to work with smaller numbers. When I look at this right here, it looks like, how confusing, how can I do this? So I'm looking at it and thinking, can I find the greatest common factor? Is there something I can factor out of both sides? When I look at the numbers, I can see I can factor out a 3. So when I do that, and remember we were factoring it out, it's like saying we were dividing by 3. I would take the 3 out front here, which just would be a 1 inside the parentheses, which I don't have to write. And over here on this side of subtraction, if I factor out a 3, I would have a 4. When I look at the x's next, I have x cubed and x, which means I can take out an x, which leaves me with x squared on this side, and 101, just the number 1 here, which I don't need to write in. And when I look at the y's, I can factor out a y, which leaves me with 1 here and a y squared here. So now, when I take out a greatest common factor of 3xy, what I have left is x squared minus 4y squared. When I go to factor that part of it, I notice that x squared is a perfect square, and so is 4y squared. I can take the square root of that. There is nothing in the middle. There isn't an xy in there. So then I remember that that means that's a difference of 2 squares. When I factor this, I'm going to have x plus 2y, because that's a square root of 4y squared, and then x minus 2y. And again, I can't forget the 3xy. That's also part of it right there. Okay, so that would be the factored form of that one. I'm going to try one more, I think, before I run out of time. Let's try 4x cubed plus 24x squared plus 36x. I know right away I'm going to factor out an x, and my greatest common factor of my number is going to be 4. So I'm factoring out a 4x. That means if you have to do this so that you can see 4x under all of it, that's really what you're doing. But when I have here, I would have an x squared. Here I would have 6x. And then this would be 9. I'm looking here. This is squared. The 9 is a perfect square. That makes it a lot easier for me. I'm going to write the 4x here so I don't forget it. And then I'm going to have x plus the square root of that is 3. And then I'm going to double check. 1 times 3 times 2 is 6. So I'm right. And this is my factored form of this. So just because you look at something and it looks really hard, if you can start by factoring out the greatest common factor, make it a little bit till you recognize it, and then it ends up not being so difficult. All right, that's it for this section.